This video is for 13.1 homework. So if you have any questions on this assignment, be sure to follow along. So number one tells us that George is building flower boxes to sell as gifts. So we need to look at the image. And so I can see here, right? It's got a bottom. So that's what's going to hold the flowers. It's got sides, it's got a front and back, but it does not have a top. Otherwise, where would the flowers wouldn't be able to get sunlight and grow? So it's an open box. So let's think about how many sides it has. So we know it has the bottom. There's one. It has two sides and it has a front and a back for 5. So we need to draw a net that represents this. So we know it can only have 5 sides. So if I look here, this one on the right side is going to fold up and over the top. It has 6 sides here. And when this one comes up, that last one connects over. These would close up. And if you planted flowers in there, you wouldn't be able to get sunlight. So what it really is it has, whoops, sorry, wrong way. Everything is backwards on here. So it's got 5 sides, right? Here's our bottom. These sides fold up. The top is open so that you can plant your flowers inside. So we need a net with just 5 sides. So it's got a bottom and then a rectangle coming out from each side. So this is the net that we want to work with. So let's go through and see which ways the net can be drawn. So we know the net has 5 faces. So we are looking for answers that talk about 5 faces. We know that this is part of a rectangular prism. So it's not a complete rectangular prism because it is missing that top. But if it had a top or a lid, then it would be a rectangular prism. So it's not a full rectangular prism, it's just part of a rectangular prism. And we know this does not have a top on it. Otherwise, your flowers wouldn't be able to get sunlight and grow. So go through and read those and find the statements, all of the statements that are true about the flower box. Number 2 tells us to find the surface area of the prism. So let's look at our shape here and decide what kind of shape that we have. So we know it's a prism, so it has a matching top and bottom. It has the base that is exactly the same. And so the base on the bottom, if we look at this bottom shape here, so it has 1, 2, 3, 4 sides. So that means it needs another rectangle too. So prisms are connected by rectangles, and it needs 4 of them since it has 4 sides to connect the top and the bottom. So let's first talk about how many faces does this shape have. So it's got the top and the bottom that are the same, the bases that are the same. It has 2 sides that are the same, and it has a front and a back that are the same. So 1, 2, 3, 4, 5, 6 faces. So let's go through and draw each of these shapes, or you can unfold it and draw it as a net. But I think sometimes it's easier just to separate each piece. So you can do it either way. So you can draw it like this and label it, or you can find the bottom, the sides, the front. But remember, each time we have 2 of those. So let's start with our bottom and our top piece. So I can see that it's a rectangle, and I'm going to have 2 of these because I've got a top and a bottom. So I definitely want to remind myself I need 2 of these. So let's go through. So let's look at one measurement of the bottom is 18. And this side here, the length is 10, or the width is 10, either one. And remember, when we multiply, it doesn't matter which one is which because of that commutative property. So we're going to do 10 times 18, and I have 2 of those. So 10, so base times height is my formula. Now I'll use 10 times 18, but I have 2 of these shapes for a top and a bottom will give me this first problem here. Okay, so now let's look at these sides here. So we've got, again, it's a rectangle, and this front and the back are the same, so I have two of those. So it's a rectangle, so again, my problem is base times height. Now let's find our measurements. So it looks like this part here, the base is 10, and the height is 4. So we'll do 10 times 4, but I have two of those. Will tell me the front and the back. So we found top and bottom, front and back. Now we need these sides here. So if I look at these sides, again, they are rectangles. So rectangle formula is base times height. So let's look at the bottom here. The base is 18. And the height, so there's no number right here, but it goes straight up and down. Can you find another measurement that went straight up and down that was the same as this line? If we come over here, it's 4, and that's the back part here, right? This is the same as this. This is 4, this is 18. So now we'll do 4 times 18, but we've got this side, the right side, and the left side. So we have two of those. And so we found top and the bottom 2 times, front and back 2 times, sides 2 times. Now we want to find the sum of these shapes. So once we have all of our pieces, we're going to add them together to find our final answer. And remember, it is still, this is inches. So I guess I can write inches instead of units. So it is still inches squared, because we're finding, right? We unfolded it and it's still flat. We only had 2 dimensions, base, height, still just squared. Okay, so go ahead and complete number 2 and come back when you are ready for number 3. Okay, number 3 wants us to look at this figure and decide what it is going to fold up into. So I can see here, right? Here's my base. And it's a square. Every measurement is 2 by 2. And across from that, right, this would connect them. This would be a side, and across we have another matching square. So since it's squares, we know it's going to make a cube. So, and all of the sides are squares, right? So it's going to fold up into backwards into a cube here. So it has 4 that connect around, right? So these 4 all connect around to make a box, and then the sides fold in. So you can see this shape here looks a little bit different than this one. This one has this piece here down here, but either way, right? Once I fold it up into a box, it doesn't matter if I fold these pieces up or if I folded them like sideways or down, as long as they connect and cover that spot. So we want 4 going across and then just 2 others, 1 on the top, 1 on the bottom. So this is going to fold up into a cube because it has all squares. So now we want to find the surface area of this. So how many faces does our shape have? 1, 2, 3, 4, 5, 6. So rectangle and square prisms or cubes always have 6 sides, top and bottom, 2 sides, front and back. So we've got 6 sides, and I know my shape is a square, and I have 6 of the exact same thing. These are all the same. So to find a square, we're going to do base times height, or side times side, since they're the same. And this measurement is 2. And this one is not written right here, but if I come and look over here, these are the same, and my height is 2. So I'm going to do base times height, and that tells me 1 of these cubes. But remember, I have 6 of them that are exactly the same. So I want to multiply that by 6 to get that there. So go ahead and do number 3 and come back when you are ready for number 4. So number 4 has a shape that looks like this. And when we fold it up, so right, we can see it's got 4 rectangles. When we know they're rectangles, that makes a prism. Triangle sides make a pyramid, but rectangles make a prism. Sorry, I forgot the word. And I can see the sides are going to fold up here, and my top and my bottom here are rectangle shapes. So we've got these rectangles as my top and my bottom. So this is a rectangular prism. So its bases are rectangles. It has 6 sides, folds up into a rectangular prism. So we know it has 6 sides here. So we're going to look at each of these shapes. So I can see that this shape and this one are the same. So right, the top and the bottom. I can see that the front and the back are the same. And I can see that the 2 sides are the same. So this one already has this net drawn for us. So we don't need to draw out each shape because it's already been done here. So what we do need to do is identify each of the pieces and find their area. So I can say, let's start with our base here is 100 by 50. And since these are all rectangles, they'll all use base times height. So this is 100 by 50. So we need to do 100 times 50. And I can just say I need to do that 2 times. So once I have 100 times 50, times it by 2 will give you your top and your bottom. Okay, so let's go on to our next one here. So let's look at the blue piece. So there's not a measurement on this line, but I can see this line is the same as this one. So we're doing 100. And now we need to find this piece here. So it's not listed right here. So let's look over, and here it is 35. But we've got the front and the back. So we really have 2 of those. And then our sides here is 50 by 35. And I have 1, 2 of those. So I'm going to find the bases, find the front and back, find the sides, and then we add them all together. So once you have these answers here, you want to add them all together to find these centimeters, squared for this rectangular prism. Okay, number 5, we're going to match the net to the 3D shape here. So this first one, you can see, is made up of triangles. So all of these are triangles. So that its base here is in the center. So we know it's a triangular what? All of the sides are triangles. Triangles fold up to make a pyramid. So this is a triangular pyramid. So which of these is a pyramid? So this is a pyramid, and this is a pyramid. But which one has a triangle on the bottom? So find the one of these that has a triangle on the bottom and folds up with a point to the top of pyramid. Hey, let's look at our next one here. We have, oh, this is my funny one. Okay, so still the same thing. It's got the 4 triangles and 1 square in the middle. Don't know why they chose to make it like this. This seems like a very hard way. So look at the base here in the center. So the base is a square. So we need a square on the bottom. And then it has triangle sides. Triangles, right, fold up to make a pyramid. So we need a square on the bottom, a point on the top. Okay, and then that leaves our last one here. So we've got 2 triangles and then 3 rectangles. So since we have just 2 triangles, right, they aren't going to fold up and meet each other nicely. So it's not a pyramid. So it has 2 sides that are exactly the same. So it's a prism, and prisms are connected by rectangles. And since it's a triangle shape, we need 3 rectangles to connect it. So here we have a triangular, since the bases are triangles, connected by rectangles, triangular prism. So find the one that has 2 triangles and is connected by rectangles. Okay, number 6. So we have this box here. So it looks like my purple one here. And we are going to assume that the box has no top. So we've got to get rid of one of these. This one is gone. It just looks like this. So it's going to fold up, right? It's going to make half of that box and then the sides. So it has an open top here, kind of like that garden box we did on number 1. So we just have 5 sides and no top. And we want to find the surface area of this box. So this time we only have 5 sides. We've got the bottom, the 2 sides, the front and the back. So just 5 pieces this time. So let's draw each of our shapes. So we know the bottom, I can see here, is a rectangle. Its measurements are 5 by 9. So 5 and 9, I know that those don't match up to what it looks like, but it'll be okay. And then we've got our front here is another rectangle. And this front also matches this back here. So I actually have 2 of these. And the measurements are 5 by 2. And then let's do our sides here. So this side is a rectangle and it matches this side. So we have another rectangle with 2 of these. So notice when we did our bottom, we only have 1. So I didn't multiply that by 2. So let's take a look at these sides here. So the base is 9 and the height isn't listed on this one, but it is back here is 2. So rectangles are always base times height. So base times height finds the bottom. Base times height finds the front, but we have the back, so times it by 2. Base times height finds the side, but we have another side, times it by 2. Once you have each of these answers, we want to find the sum of them, so add them together to find the surface area of this box with no top on it. Let's go ahead and do number 6 and come back when you are ready for number 7. Number 7 tells us that Jen is carpeting a room, and here is what the room looks like. So it is a trapezoid. Look at the figure. How much carpet will she use? If you remember, trapezoids, we want to take base 1 and add on base 2, because that is going to give us this parallelogram shape. So we add our bases, base times height, cut it back in half to get back to our trapezoid. So base 1, the top here is 4. And then base 2 here, we know, right? We know this part is 4. This part is 1. And this part is 1. 4 plus 1 plus 1 is 6. So base 1 is 4. Base 2 is 6. The height, straight up and down, connecting the bases, is 4. And then we'll cut it in half. And that will tell us how much carpet she needs to buy. Number 8 is a coordinate grid. So our vertices, remember, first we have X and then Y. We always go over, then we go up or down. So -4 to the left. Whoops, I didn't mean to click there. -2 down. So we're going to graph them and then connect them in the order. So next we have over +4 down -2, and then we're going to connect those. So I want you to see if you can finish these shapes, and then you need to select all of the correct answers. It looks like I forgot to capture that. So decide, is that shape a parallelogram? Are the sides parallel? Is it a rectangle? Does it have right angles? Is it a trapezoid? Does it just have one set of parallel sides? And there could be more than one answer, right? Like this square here is also a rectangle because it has parallel sides and right angles. So its best name is a square, but it can have other nicknames. So go through and graph that and then select all of the shapes or statements that are true about this shape here. Hey, and number 9 tells us that Brianna can rent a scooter for $15. So that's just, you have to pay $15 to take the scooter. And then every mile you ride is 50 cents. So we're going to write an equation in which T is the total cost to rent the scooter and M is the miles she rode. So T is our total. So we know when she goes to the scooter store, she has to give them $15. And then she's going to add on 50 cents for every mile. Per mile means times M. And we can write an XM, but that's going to confuse people, right? XM, if I do 50 cents XM, that looks like an variable. So the best way is just to times it by M, have that coefficient, and our variable means to multiply. So they have to pay $15. Then if she rides 1 mile, she'll only pay 50 more cents. If she rides 2 miles, she'll pay $1. And that will, so if I rode 2 miles on the scooter, that's $1. 2 times 50 is $1. Plus the $15 would equal 16 total dollars. So let's go ahead and complete our table. So if she rides 5 miles, I'll do this first one with you. So we're going to do 0.5 times 5 is 25 with 1 decimal place. So it would cost her $2.50 to ride 5 miles plus the $15 she already had to pay makes that $17.50. So you're going to do this. You're going to do 2.5 times 10 plus 15 gives you your total. 15 miles times 0.5 plus the $15 is your total. So go ahead and complete that table. If you have any other questions on your homework, please be sure to let me know and we can set up a time to meet together.